We have a system here of two cars which are connected by a spring. I will turn on the air shortly because the air makes a lot of noise. These are two cars connected by a spring, and I will give these cars a certain motion, and they will go in this direction, and they will oscillate in a weird way because they are connected with a spring, and I keep them connected. And it would be nearly impossible for us to evaluate the motion of these two cars individually. But if I give the whole system a certain velocity, and then they go like this, and they keep going like this, and maybe crazy things, momentum of the center of mass will not change. Only of the center of mass, not of this car, not of that car. That's the uniqueness of the center of mass. And so the center of mass will just laugh at us and ignores all these motions and will travel at a constant speed very nicely. So if you concentrate on that little object, you may be able to see that. You may need a lot of imagination to see that, because you're going to be distracted by the weird motion of the other two objects. This is the center of mass. It's right in the middle. The objects have the same mass. There we go. You see how complicated this motion is of the individual cars? Can you see that the center of mass is moving very uniformly, or can you not see that? Well, you think you can see that. You have a lot of imagination. But I will help you. I will turn off all the light and only turn on ultraviolet light. And ultraviolet light will interact with that little ball, the center of mass. And when I then make it dark, you will only see the motion of the center of mass. And then you can really see that the center of mass moves in a very civilized way. I'll bring it out here again. Okay, so now I'm going to help you to concentrate. Are the timers off? Yes, timers are off? Okay, dark. Let your eyes get used to the darkness. Okay, I'm going to do the same thing. And now look at that center of mass. And we know that these cars are doing crazy things, hard to predict. But the center of mass behaves decently, beautifully. Constant velocity. I can let it go backwards, so you can enjoy this once more. Center of mass motion, in the absence of external forces, has a constant velocity. When I throw up a hammer, then the hammer will do very weird things. The hammer will start to tumble and rotate, but the center of mass will behave in a civilized way. If I throw up a hammer, then the center of mass, and only the center of mass, will just go along a perfect parabola, as if it were just a tennis ball. Now, at one point, I will do it with a squash racket. At one point, the squash racket may be like this, and at another point, the squash racket may be like this, and a little later, it may be like this. But the center of mass of the squash racket will perfectly go along a parabola. And so we have here a squash racket, and we have here the center of mass. I have also here a regular, well, it is not quite a tennis ball, but close enough. This one, you would expect it to behave perfectly like a parabola. From this one, you would not expect it to behave like a parabola. Let me throw this one up in light, and you will see that it is a very strange motion. If I show you the whole thing in UV, then you will see the same kind of beautiful parabola as you would see with this ball. Something like this. Forget the fact that it lights up. You remember that was the last lecture that I wanted to remind you of. So now we're going to turn off the lights, and I want to show you the motion of the center of mass. You see the center of mass here? Can you all see it? Okay, there we go. You ready? Concentrate only on the center of mass. Nice parabola or not? Shall I do it again? You see the center of mass? Can you see it? You can still see it, right? A wonderful parabola for me. All right, enjoy the presence of your parents. Have a good weekend. See you Monday.